When we search for life out there in the cosmos, we usually look for planets kind of like ours. But what if life could thrive on a world that's, well, way, way bigger? Today, we're diving into a really cool cosmic mystery, a question that's right at the heart of our hunt for alien life. On the surface, it seems like a pretty simple question, right? But the answer involves this incredible cosmic battle between gravity, gas, and a wild tipping point that separates the rocky worlds that could host life from the giant, uninhabitable ones. Okay, so let's get into it. Our investigation is going to start with a type of planet that is, believe it or not, super common out there in the galaxy, but we don't have a single one in our own solar system, and they are our first and our best clue. Right, so this investigation kicks off with a class of planets called super-Earths. Like I said, they're everywhere in the galaxy, just not here. And they are the prime suspects in our search for the biggest possible world for life. So what exactly is a super-Earth? Well, put simply, it's a rocky world. Like Earth or Mars, but just scaled way up. It's got more mass than our planet, but not so much that it balloons into an ice giant like Neptune or a gas giant like Jupiter. And this is where it gets really exciting. I mean, we're talking about planets that could be up to 10 times the mass of Earth. For the longest time, scientists figured a bigger Earth might actually be a better Earth, with a thicker atmosphere, a stronger magnetic field to protect it, more active geology, all things that could be fantastic for life. But, and this is a big but, here's where our story takes a sharp turn. It turns out you can't just keep piling on rock and metal to a planet forever. There's a fundamental law of physics that stands in the way, a point of no return. So what's stopping a super-Earth from becoming, a mega-Earth? Well, the answer is gravity. And gravity is greedy. Here's how it goes down. As a rocky planet's core gets bigger and bigger, its gravitational pull gets stronger and stronger. Eventually, it hits this critical point where it's not just holding on to a little bit of atmosphere anymore. Instead, its gravity goes wild, and it starts sucking in all the hydrogen and helium gas in its neighborhood. It wraps itself in this thick, crushing envelope of gas, and poof, it transforms into a mini Neptune or even a gas giant. This whole process creates what astronomers call a forbidden zone. It's this range of size and mass where, for all intents and purposes, stable rocky planets just can't exist. They either stay small enough to be rocky, or they cross that tipping point and become a gas world. There's almost no in between. Now, this was a fantastic theory, but science needs proof. And astronomers got it in the most spectacular way you can imagine. They found a planet that is the perfect, absolutely bizarre piece of evidence for this cosmic rule. I mean it. They discovered a world so weird it looks like the exposed, naked core of a gas giant. It's like a planet that crossed that tipping point, and then something went horribly, horribly wrong for it. Get this. This object, its name is TOI 849b, is an absolute beast. We're talking about the mass of 40 Earths, all packed into a body that's only about the size of Neptune. Just let those numbers sink in for a second. It's massive enough that it should be a gas giant, but it's unbelievably dense, which tells us it's mostly rock and metal. And the most important part, that huge, puffy atmosphere it should have grabbed, it's gone. Just not there. Scientists actually have a name for this kind of planetary zombie, a Chthonian planet. The main theory is that TOI 849b was a gas giant, but maybe it flew too close to its star and had its atmosphere blasted away. Or maybe it just ran out of gas to collect before it could finish the job. And this is why this discovery is such a huge deal. TOI 849b is the smoking gun. It's physical proof of that forbidden zone. It shows us what happens when a planetary core gets too big. It doesn't become a habitable super-Earth. It becomes the naked, fried heart of a world that tried to become Jupiter and failed. Okay, so we've got the theory about the tipping point, and now we have the real-world evidence from this bizarre zombie planet. We can finally put all the pieces together and actually answer our original question. So it turns out, both our computer models and our actual observations of thousands of exoplanets all point to the same, surprisingly clear answer. There really is a size limit, a line in the sand that separates the rocky worlds that might be habitable from the gassy ones that aren't. And that number, the line in the cosmic sand, appears to be right around 1.6 times the radius of Earth. So here's the bottom line. Once a planet grows past about 1.6 times the size of our own, its fate is pretty much sealed. Its gravity just becomes too powerful to resist, and it starts hoarding gas, building up a thick, crushing atmosphere. And for life as we know it, well, that's game over. That is our cosmic size limit. So there you have it. For a rocky world made of the same stuff as Earth, the limit seems to be about 1.6 times our size. Case closed, right? But what if a planet wasn't made of ordinary rock? What if it was formed from something way more exotic and a whole lot stronger? Which leads me to one final, absolutely mind-bending idea. Some theories out there suggest that carbon planets could exist, worlds where the pressure inside is so intense that it forms a massive core of pure diamond. Could a world like that, an exotic diamond planet, defy our tipping point and grow even bigger while staying habitable? Well, that's a question for another day.